All right, hi everyone. It's 1:30 and people are still getting back from lunch, so we're going to give folks just a few more minutes to fill up these seats, and otherwise we'll get started on the talk real soon. I didn't actually I didn't even know there was a basement down here, so it's a testament to all of you guys who walked down. That's good. In the meantime, I guess we can just, how many people are familiar with Varnish? All right, so a healthy amount. Okay, that's pretty good. I guess I'll have a lot of mixture of different topics to mention, so I'll try to make sure that for those of you who aren't familiar with Varnish, we'll at least have some idea, some conceptual ideas, some strategies for, you know, what it does, what it can do for your organization. For those of you who have used Varnish in the past, it'll definitely provide some insight on hopefully some best practices, things that we've learned, lessons learned, methodologies for implementing Varnish, and you know, some takeaways to take back hopefully. I noticed a lot of learning going on at Varnish, so I'm you know, happy to kind of present what we've found ourselves to all of you, and, you know, and hope that continue to educate the community on Varnish and other technologies. So it looks like just give folks a few more minutes to join in. There's some seats over here, seats in the front if you guys want to sit down. Okay, well, let's go ahead and get started. All right, so cashing in on Varnish. When I was doing this, I debated whether I should have the CH or the SH, right? Because there's obviously a double pun by saying caching with an CH versus SH. And you know, after thinking about what the intention was, I said it should be SH. And that's because when you say cashing in on, you're talking about profiting on something. And that's part of the message that I'll give is how we can profit individually by leveraging Varnish within the infrastructure. Not just from a monetary perspective, from a time perspective, from an experience perspective, from a operations perspective, saving time, and so hence the SH. Somebody actually asked me, like, did you really mean CH? Because we can change the title if you need it. No, it's fine just the way it is. So who am I? My name is Rafael Barrero. Thanks for coming. Appreciate you all being here. I work for the Walt Disney Company, for the technology arm that is named DTSS, Disney Technology Shared Solutions and Services. And I support ABC. My team does. We focus on systems architecture, infrastructure, cloud, application support, operations for ABC, Watch ABC Family, the Watch Disney channels, family of streaming services, the OTV stations, the DATG television group. We also support news in New York, and we also have the fun of supporting pretty big events like elections and the Oscars, which are tomorrow. It's actually a surprise I'm here because we've got a lot of work getting ready for tomorrow. So this is kind of our scope. This is what we do. And so what we want to talk about is Varnish. absolutely we have to go in depth. I want to, get across the message that, there's a lot of detail to Varnish. There's a lot of intricacies. There's a lot of nuances and configuration that needs to happen to make it work well. I want to talk about automation, configuration management. Definitely want to talk about best practices, things that we've learned, operational visibility, and then, getting this whole thing running is also a collaborative effort with engineering teams, software teams, application teams. That's at a glance. All right, so what is Varnish? Well, if you look at Varnish's webpage, it says it's a web accelerator, right? This thing was written from the ground up to be an HTTP web accelerator. And it sits in front of a web server and caches content, right? So content can be a lot of different things, right? The definition for content is varied, but primarily it is the web accelerator. But that's not all it does. That's its primary focus, but certainly the way that you configure it, the way that you use it and implement it can be used to do very many different things. It's not the only type of reverse proxy that exists. You also have things like SCuid, which has been around for a very long time. Nginx, Apache Traffic Server, F5 also has reverse proxy capabilities and caching, compression, etc. So those are the others in the space. There are others beyond this. Those are the ones that I've thought that there were a lot of parallels to. Different approaches to each. I think one of the things about Varnish is that it's been written from the ground up to be super fast. They've taken a look at SCuid. They've taken a look at how appliances do it. They said, how do we develop a better product around this? And so they've really taken a lot of time to optimize performance for this HTTP accelerator. So for those that don't know, Varnish sits in front of the application or web server, right? And it caches content. So at the top, you've got the concept of cache misses and cache hits, right? If you've got a client on the web that's accessing your application or site, you put Varnish in front of the application server or the web server, right? Just as it says. When you make a request, an HTTP request, right? It will go back to the back end and say, hey, I got this request. I need a response. Give me the response, and I'll send it back to the client, right? Instead of it doing directly, right? We're not putting the web server right in front of the client. We don't want to do that because Varnish will cache that if it's seen the request a second time, which then becomes a cache hit. The value here is that that request, that second hit, doesn't go back to the original web server. So immediately you can say to yourself, well, we've got a web server. It's getting hit by clients, users, applications, maybe automated scripts, etc. And it's just hitting the web server directly every single time, right? Maybe unnecessarily, and also at some sort of cost, right? Because there's a response time cost. With Varnish, with appropriate configurations, you can set it such that it sits in front of the web server, receives the request the first time, says, all right, I haven't seen this request in a certain amount of time, so I'm going to hand it back. I see it again. I've got a rule that says, hey, I got to cache this thing. I got to hold on to it. I got to keep it in storage in my object store, my cache store, and then I'll just respond with what I have. So it doesn't have to go back to the web server. You save almost that round trip time. Right? So you're the man in the middle. The man in the middle doesn't have to go back and get the message to respond with the same response that it would have the next time. And this is important, and this is essentially the essence, for those of you who are new to Varnish, of what Varnish does. So Varnish is a daemon, right? Runs on probably a lot of Unix different variations. There's a daemon configuration that's part of this. Out of the box, it has a lot of defaults. And the default config on a RHEL system is in etc sysconfig varnish or varnish underscore instance name, whatever you want to configure it to. And the importance here is the parameters, right? Because as I mentioned, the cache hit piece is highly tailored to whatever application you're running in the background and actually the performance you want to get out of it. So there's some specific things that I call out here, and this is not the entirety of the config file. Things like reload capability being enabled, where the VCL is, and I'll go into that later, which is the configuration file for how to interpret requests coming in. The Varnish storage size, so how much cache store to keep. The method to use to store that, whether it be memory or disk. Thread pools, pool minimums, and pool maximums. These are all highly important, and they're not in the main request config file. These are outside of the file, and these things here are very tunable, and this is how you can get a degree of performance out of Varnish and how you scale up vertically, essentially, on a single node. But we'll get into more of this later. So we'll come back to that. One of the key features about, I think, the reload feature, enabling that, is that if you do that, you essentially don't have to restart the server when you want to change the VCL file around. And the importance there is that if you restart Varnish, you basically empty out your cache if it's stored in memory. And you want to store in memory because it's really, really fast to store in memory versus storing on disk. So if you need to change the VCL and say, I want to update the TTL, the time to live for a specific object, you can do it without invalidating all of your cache. Come on in. You guys want to? Just no worries. So that's important. I think another important thing to call out is the malloc, right? It's using memory off the OS instead of using it on disk. There is a storage option that says you can use disk, but frankly, you don't want to unless you absolutely need to, or doing something special. Maybe you're copying that around, or you have specific reasons to do that. But using the storage in memory is extremely efficient for the application. That's really what it's designed to perform best at. All right. So I mentioned VCL, and in part of the daemon configuration is the path to where this VCL file is. The VCL file can be quite long. Looks like C, right? It's a domain-specific language designed to describe essentially the workflow of a request that comes in. So there's a life cycle to what happens when the request comes into Varnish. It does just go back to the back end, get the response, and then send it to the client. However, there's a lot of intricacies in how it does that. There's a lot of different properties in the VCL. And so while I'm not going to go through the entire file line by line, I have laid some groundwork for things that we're going to discuss later in the topic. And so I've positioned here, it's kind of towards the top, you have what's called probes and backends. So a probe is how you inspect the health of one of the backends. Right? So the web server that's behind Varnish, that we're putting behind Varnish, we're going to call that a backend. So those are requests that fall back. If a web server goes down, you want to know about it, right? And if it goes down, you also want Varnish to know about it so it can take action. So the fact that it sits in front of your web server and caches content is one thing. On the side, it says, well, I also want to know how much traffic I should send to it, how often, and if it goes down, how to put it back into rotation, take it out of rotation, right? And so this is kind of the definition for that. I've got a sample one here, and this is a bit verbose because you can include the probe within the backend statement as well. But when you're looking at a really long config file, it's almost good practice, just like you would in programming, to kind of compartmentalize some things, make them modular so you can reuse them easily and quickly, and just reference them later. So we've got a backend here, a sample backend called main site server 01. It's got a host, it's got a port, it's got the probe defined, which the probe is a URL that it hits to know whether Varnish should pass traffic to it. So if the backend server is unhealthy, that server service/service health wouldn't or shouldn't come back. And that's how it would know, hey, don't send it back to the backend because this backend is unhealthy, it's sick, so just move traffic onto another one. And Varnish will do this for you automatically. There's no programming that you have to do beyond configuring the probe and the backends. You can configure backends without probes, but then you wouldn't know if they were down, and you might be serving 503s or any sort of 500 back to the clients without really knowing, and we want to avoid that. Some other important pieces of the backend site I've gone through, and some of these are optional. You got connect timeouts. That's important. So when you go and make that connection back to the backend, it's typically in the same data center, but not always. You might have a disparate, if everyone can just kind of write down your questions and hold on to them for a second, and then I'll address them at the end. You've got these connect timeouts. You got first byte timeout and between bytes timeout. So this is pretty much kind of what you would want to see in an application. This is ideal, actually, where, hey, I didn't get a connection from the back end in a certain amount of time, right? And so I'm going to say that maybe because the application is very, very heavy, maybe you've got a really slow web server, and it takes, 500 milliseconds to respond. Or worse, what if it takes, 60 seconds to come back with any sort of response? But generally, connect timeout should be very low latency, right? Because you're just expecting that socket to connect. And then the first bytes timeout that's where it's important. So you might be able to connect to the PHP web server behind it, right? Because that's Apache HTTPD or whatever web server you prefer. You make that connection, and you've got that socket open, and it's connected. Now you want to start sending data over that. From Varnish to the back end, it's asking for this request. So it received the request from the client and said, go get me index.html or index.php or just give me slash. And now go to the back end. And it made the connection. It's saying, okay, well, this particular request, this service endpoint, maybe it's an API endpoint, is taking quite long, right? Because it's generating a bunch of data from MySQL or some sort of back end, and it takes its time to do this stuff. Web server gets it, starts sending it back to Varnish. And when it does that, it might not be, half a millisecond. That could take 2 seconds, 5 seconds, 10 seconds. Could take sometimes up to 60 seconds for some queries, for some servers. And then between bytes timeout. So this is just another layer where I've got the response, but maybe it's slowed down for some reason, and I need to wait a little more to get that next byte, etc. So this is the knowledge that Varnish knows. Who are my backends? You can have multiple backends, and then we'll talk about how we use Varnish also as a load balancer to do multiple backends and multiple types of backends. So not just main site. You could also have main site. You could have side site. You could have API site. You can have static site. You can have dynamic site. You can call them whatever you like. Build logical pools for these backends, group them together, and then use those individually as pools. Right now, it just looks like there's one server, but that's just because that's all I'm showing. And that's this next piece. So directors. Within the VCL, again, at the top where you define kind of your environment, right? That's where you define what your environment kind of looks like from an infrastructure perspective, where the application servers are, how to get to them, and what are those connection limits. Directors are essentially, you can think of it like load balancing pools. Right? If you're familiar with F5s or any load balancing technology, this is like a pool. And so you define a director, you give it a name, that name's important, and then you put backends in it. So the backend that we saw before, main site server 01 is that first backend line. So you have 3 backends in this particular pool, we'll call it, and this director is doing a round-robin type load balancing. So you have different algorithms that you can define. 1, random, 2, client, 3, hash, round-robin, or DNS. Depends on what you prefer. I think generally speaking, most people go round-robin. There are certain things that you might want to use hash for. So if you wanted specific URLs or endpoints to be hit by a specific set of servers and you want to optimize that cache really, really well, you go that route. DNS-based round-robins give you the flexibility of saying, well, I just have a kind of an unknown backend, and it's got a TTL. It's got it's a domain name on the back end, so it's not an IP address, and so you're using a DNS request to go back to it, which um, could could cause issues if that IP address changes behind it. So um, the point is that you want to get directors configured for all your logical pools. So you have main site, you've got API site, you've got static site, you've got all different types of backends. You kind of cluster them together and say, look, this is my PHP cluster, this is my middleware cluster, this is my Tomcat cluster, this is my Solar cluster. You can go all the way down the line and have it funnel traffic to each of those pools. VCL. As we go down the VCL file, we get into some specific subroutines. And the VCL is actually made to look a lot like C. I think the developers are C-based, and that's why it kind of looks like C or some Perl maybe. In the VCL receive function, there are certain subroutines that are defined for you. There's blocks of code that say, when I get a request, this is what I should do, and that's what the VCL receive is. Everything kind of funnels into VCL receive. VCL receive is kind of the entry point for all this, and I'll show a kind of a workflow diagram about it in a little bit. And when traffic comes in, it hits VCL receive, and it needs to know what to do, and this is how you define what to do. So you can define specific things for HTTP requests. And HTTP requests are really important. The guys on my team, myself, the people we work with around us, HTTP is kind of the next, like your second language or your third language that you really need to know, because there's a lot of details that can make or break your site or improve it. So headers, whether or not, for example, here we've got a request URL, and if it says / go to the backend that is called main site. So we say for things that are /, go to main site. Else if they're going to a cross domain or the favicon image, go to a different backend that is serving really just flat files, right? Which could be different from your dynamic site. Otherwise, issue a 403. Right? Now, do you want to issue a 403 from Varnish? That's kind of up to you, and whether or not you want to do that from the backend or from Varnish. Sometimes you could want to do it from both sides. This is just an image I put together of what that means. So the traffic comes into Varnish, and then it decides based on these rules. So there's business logic, right? So you, along with your teams, say, for this particular thing, you may be already doing this, by the way. You just add it with a different tool, with a different appliance. And so this is kind of the software-based load balancing solution here with Varnish. That basically says with /, I'm going to go to this cluster, /API, I'm going to go to this cluster, /crossdomain.xml, I'm going to this cluster. If a specific user agent comes in, so let's say I've got mobile, I care a lot about mobile, and I want them to go to a dedicated iOS cluster, or I want them to go to a dedicated Android cluster or an Apple TV cluster, you can do that. You can also say, I got this specific host and I want to do something else, and those requests are going to be served by this other cluster. And you can go as far as you want with this. You can define those business rules and how you basically handle those requests. So you detect them and you funnel traffic. Apart from just funneling traffic, what's not shown here is the things that you can do with VCL to rewrite headers. So you can say, I received a request for host abcnews.go.com. ABC News receives a request, and it matches this host name, it matches this path, and it turns out that I actually want this particular traffic that's going to this path to be sent to another backend that's expecting a different host header, right, than the one that came in from the front end. So it may have come in as host abcnews.go.com, but it may need to go out using some sort of ramp search index or something, or some specific header, or something you want to define for a backend that's required. So let's say that you want to send a specific header that would tell your application to do something if it saw a specific type of traffic. You write that in, and it works almost kind of like mod rewrite, where you can say and you can manipulate the headers all the way through. VCL hash. VCL hash is important if you want to say, apart from just caring about the path that came in, I also care about the header. and build that into the cache key. VCL fetch is the other one I'll show, and VCL fetch is important because this defines those TTLs that I talked about. So how long Varnish holds on to something. How long it holds on to something is important because, as I mentioned before, the purpose of Varnish is to cache content that's coming into the web server and sit in the middle and say, you don't need to go back to the web server because I've already got that content for you, and here it is. So how you define those rules is by using the TTLs and cache control headers. So here I've got some just sample cache control headers set for specific different types. Cross-domain, which should really never change. We're setting it to that extraordinary number, which might be like a year or something. We've got /s, which could be a static path to 30 minutes. You've got JS and CSS that can go to a day, and that's fine because our developers, even though they might change their JS, they're versioning their JS every time it gets pushed out, so it doesn't matter. And typically Google likes it to be like more than a few weeks, probably more than a month. So if you're versioning your JS, it doesn't matter that it's got a long cache time because you're not going to purge cache because you want to release. You just release a new version of it and make sure that your code is referencing that new version. So that works for us, and it keeps things snappy. Images as well, cache them for a long time, and then you've got a catch-all, right? So if it doesn't meet any of those, just keep it in cache for 5 minutes. So what happens is that traffic comes in, the first hit will end up in a back-end hit, and then it'll keep that in memory for 5 minutes. After 5 minutes, it detects another request, and it's got to go back to that back-end. But during those 5 minutes, it's serving it from cache, which means it doesn't have to go back to that back-end. And I'll go more into load testing and numbers in the future. This is kind of a diagram of a workflow of the life cycle of a request, HTTP request that comes in. You've got lots of different functions and features within Varnish. There's a lot of great documentation that goes over this, but the basics is it comes into VCL receive. You have different methods that you can use depending on the traffic. And again, this is really dependent on how you want your application to perform, the kind of business rules and requirements that your application has. Maybe you just want a straight TCP proxy, no cache, straight to backend, then you might just use pipe. If you don't want to do caching at all because this is really sensitive data, you're doing some sort of authorization, entitlement, tokenization thing that is not tolerant to caching, then you just do a pass. Doesn't mean it can't go through Varnish, just means you don't have to cache it. So it can still act as that middle layer, right? Your load balancer, and just not cache it. So again, I go back to it sits in front of your web server and caches content. That's not all it does. It can do other things, and there's other ways to get around these things. We've had lots of different issues implementing Varnish, which I'll get to. But one of the things is developers saying, well, we can't cache entitlement, we can't cache ads calls. Right? Those are things that typically, when you're generating tokens, they need to be individual. They can't be copied. They can't be shared. You don't want to be serving someone else's cookie to someone else. So there's certain things where we say, all right, this specific type is just a pass-through, and there's no caching. So I'll answer the question, why Varnish then, if you're not going to do any caching? The purpose of this is to show that it goes and grabs an object in cache, and then we'll deliver it to you. If it doesn't have it in cache, or you don't want it to cache, that's kind of the route. Yeah. So I'm going to revisit this just to say that based on the VCL, you can force things to be a cache miss if you want it to all the ways go back to the back end and grab a dynamic page, because this particular page for you is really important. These parameters, when you see them, you never want to cache when you see these or this header, and you can do that. And you can continue to see those cache misses, and that might not be a bad thing. You can always calculate what they are when we go into the monitoring piece of it. Varnish debugging, Varnish stat, Varnish log, Varnish ADM. These are all tools that you should know if you're using Varnish. Varnish stat will tell you kind of a snapshot in one plain C or interactively what the cache hit ratio is, what your client requests are, what your response time is, what memory is like. Varnish log will show you the actual packets that are coming through. Varnish ADM is the administration tool to issue commands to Varnish to do things like invalidate cache, purge cache, ban cache, or other things like ask for detailed information about the health of the backend servers. This is what the output might look like. Varnish log, I'll just mention here that sometimes you want to see what's going on between your load balancing tier and the application tier, so you'll go onto the application if you've got access to it, or the app server, and you'll TCP dump. You'll see what's coming in the front door. You might go onto the load balancer, and you might TCP dump from there to see what's coming there and seeing what the responses are. Varnish, with Varnish sitting in the middle and looking at Varnish log, it's essentially collecting all the data and breaking it down for you. So, TCP dump is still great, but if you've got Varnish log, it will take the HTTP transaction and complete it for you. Right, so it'll say, look, this is what the session started. You've got the request URL, the request protocol. All these request headers came in. It's doing its hash operations, and then down below we'll get to the response, so the transmit. So it does the receive and transmit data. This is really great for debugging, and it's basically packet tracing built in. And if you run this command or run a command like this one specifically is looking for a request header, receive header that was Apple TV with a resolution of 1080. Right, so that's something that Apple TV uses in its header, and we're looking for that because maybe we've got an issue with 1080p devices. Maybe somebody's using 1080p and getting a weird logo or a bad request, right? So we want to look and see. And when the backends are misbehaving, you've got 503s coming back, you've got 400s coming back for specific things. You want to know exactly what was given back to Varnish, and this tells you that. The tags there, I use -n to name the site, so main site is the same one we got before. C is to see the clients, and M is for the tags for the regular expressions. Varnish stat. Varnish stat, these are sample Varnish stats I've taken from some servers we have. Tells you uptime, cache hit ratio, gives you real-time request per second, since boot request per second, and even gives you kind of a quick description on the last column there about client requests, connections versus requests, cache hits versus cache misses. It doesn't break it down for you and give you the percentages, but we'll go into that later because this data, you can with the -1, it will just export it out, and if you've got a good monitoring tool, you can basically parse this and inject it into anything, graphite, ganglia, Xenos, anything that you want to use. All right, so that's kind of the VCL, in-depth Varnish piece. I think a lot of that we'll cover in general overall, moving along to automation. So the benefits of automation, one of the things I didn't go through that I noticed a lot of people do on the web is to show how to install Varnish. And it's good to show that you can download an RPM, run this command, goes here. But frankly, nowadays, the way that we're installing Varnish and deploying Varnish is all through Chef or through some sort of configuration management tool, which means that I don't really care about the installation. I just want to know that it happened well, and that if I really need to dig into how something's supposed to work, that I can go to the recipe and just read through the steps that they went through to do the installation, set permissions, create users, etc. The benefits of this is that obviously you have to deploy this into your environment, or if you want to make it simple. Maybe you're doing a one-off, and you're saying, okay, well, maybe it doesn't make sense to go through all the efforts of getting a cookbook off the the internet or developing this recipe. Most of these cookbooks and recipes are online anyways. You could look at Opscode has a good supermarket. There are others in the industry, Rackspace, a bunch of cloud providers that come up with their own recipes and cookbooks for Varnish. So I would suggest looking at those. If you're using Puppet, I'm sure that there's a lot of that too. And then you got to consider yourself, well, what if I want to deploy this often, right? I want to make a change, and I don't just have a one-off. I've got 2, I've got 5, I've got 6, I've got 10, I've got 20, whatever it is. You want to make that easy on yourself. So, the old way of doing it was, you've got a fancy script, and with SSH, you kind of go and blast through a for loop and go make that change. With Chef, all these values, all these files, the configuration, daemon configuration file that I showed in the beginning, the VCL file, they're all become templates. And you kind of set those attributes based on your environment, based on the type of server, your role, and it kind of just brings all that stuff together and deploys it for each individual server based on what you need. So that's a big benefit, because you don't, if one server, going back to the for loop thing, right? If you're for looping through your servers and you want each individual server to have its own IP address, right, within that config file, you need to also say, okay, well, this server has this IP address, this server has this IP address. So your for loop just got complicated because now you've got individual things that you've got to configure. And then if you're in the cloud, it can get really complicated if you're doing like auto scaling, and you say, well, I really need to jump up to a few more Varnish servers to take off the load off the back ends, and you hit that button to say go to 10 or go to 11, and you don't want to have to do that by hand. Right? You want to sync stuff to run. Dynamic VCLs. Again, I mentioned templates. The idea of using a template is great, because I'll show this later, how you can essentially go through and generate specific things and push them out quickly. If you're doing multiple varnishes, obviously this is important. You can also get cookbooks or develop a cookbook that loops through something and deploys multiple instances on Varnish on one node. Right? This is kind of a design pattern question. Do you do multiple varnishes? Do you do a shared varnish with multiple backends and multiple directors? Or do you go the route of saying, I'm going to have multiple instances of Varnish on one server, right? I might have a beefy server that's got 64, 128, 384 gigs of RAM. I've got a lot of RAM to go around, got a lot of CPU power to go around, and frankly, I don't feel like I need to provision a whole nother server just for Varnish. Well, you can run another instance of Varnish on it, and just take up a few gigs of RAM here, and on you go. So that's more of the shared cluster, shared Varnish cluster idea. Self-registration with load balancers. This is not Varnish itself that does this. This is a concept that we have where if you come online, you should register with the person above you, right, and let service discovery happen, right? It's part of service orchestration. And so one of the things that we do is when we come online, we register with the ELB above us or with the LTM above us, and then the application servers behind Varnish will register with Varnish. One good thing about thinking about automation with Varnish is that if you have a traditional appliance like F5, right, you've got big IP, and you got to go in and use the interface. We've got a lot of nodes in our F5, and so once you get to like hundreds or thousands, you start to run into really slow response times from that interface. And so you've got to maybe result on the command line to get those things done. The APIs aren't always nice, but we're basically saying put Varnish in front of everything. That's what we're saying, right? Whether it's your app server, whether it's your web server, if it talks HTTP, put this in front of it, so then you can say, well, I know how to deploy VCL quickly, and I can put things into rotation, things out of rotation, I can change TTLs, maybe I want to cache, maybe I don't want to cache. And so instead of putting those app servers directly into the LTM, you put them into Varnish, and then you can have a dynamic Varnish configuration that's a little bit more flexible. Cookbook basics. Single tenancy versus multi-tenancy, I mentioned that earlier. Most cookbooks just say they lay down a Varnish install, they go through it, they get the VCL laid out, it configures parameters for one daemon, and then you've got your VCL. There are other cookbooks. We've got one that we built internally that does multi-tenancy. Multi-tenancy is just the concept of, hey, look, I've got this like array of Varnish instances that I want to set up, and you just loop through that, and you create those VCLs and those Varnish configs, those daemon configs, multiple times on a single node. So when it bootstraps, you basically, boom, you've got 4 instances, just like the last node. You've got 4 instances on the next node, and so on and so on. And that way you don't have to run through you obviously don't have to install more than once to get a second instance, but you wouldn't have to hand configure it. One thing that we've found is that you do want to separate the install from laying down your VCL. So if you have a cookbook that installs Varnish, we say just leave that nice and tight and keep it untouched. Right? So you may have gotten that from the community, and that might get updated, and then you might feel this compelling urge to say, well, I've got it right here. I can just load my specific things into a new recipe within that cookbook. We say you should just have a different cookbook that lays on top of that. It maybe inherits from the original cookbook, and then just does your specific thing in it's kind of a compartmentalized fashion. So now if the community makes an update, you don't have to go down and update that and go through the diffs and figure out what happened. You kind of separated that and kept it in its own self-contained repository. Data-driven VCLs. I think this is interesting. I'm not sure how many of those of you who are using Varnish are doing this. I mentioned earlier that you can create backends and directors by hand. You can go and say, I have this server. I've got server number 2. I've got server number 3. But when you have an environment that's elastic and you're provisioning, several servers at a time, or maybe you're using auto-scaling groups, and you've got CloudWatch that's triggering certain things to spin up, given certain monitoring metrics, then if a new server comes online without you even being awake, how does Varnish put that thing into rotation if you're not awake? So I talk about that in just a few slides, but you want to do that. You want to think about how can I write my VCL in such that if a new server comes online, that it will find it and put it into rotation automatically. And then you can, obviously it's a template, so you can do what you like with your template and insert certain things, headers, tracking, debugging tools within there. This is pretty dry stuff here, but we've basically taken, this is the sysconfig file where you manage where your VCL is, how much memory to use, your admin port, your listening port. This is a snapshot of what those values need to be. So you basically template that all out and you loop through it, and you generate your config files. Basic service discovery. Here you've got a definition down here that says the search string. So within a template, and this is again making your VCL data driven, you say I'm looking for a specific backend rule and a specific Chef environment. So that's important for us because if you're using Chef and you're using Chef environments, then you can say, well, my Chef environment is prod versus QA versus dev. And then all of a sudden, if you don't include Chef environment, you might have just put in dev servers, QA servers, prod servers into one big pool and make people unhappy. This is the actual values that you can store in an environment or in a role. Right? So you go through here and you say you define those things. This is what I want the name of the VCL to be. This is what I want the port to be. This is what I want the TTL, default TTL to be. And then you can also define your backends and directors here within your roles or environments. And that way your recipe will go through and says, oh, I detected that. Huh? All right, I'll send this. This is part of the materials for the conference. So I'll send this. The presentation will be available to everybody. This is the VCL, and although you might not be able to see it, I'll kind of walk through it. So you've got a probe, right, and it populates the fields here based on the values that you put into the other file. Over here you've got directors, right, and so you want these directors to be automatic. You could have just static text here for directors, like I showed in one of the first slides. But this essentially loops through and says, if you find this director in the config, this is what you should set, and so on. Service discovery. Auto-registering with Varnish service. I think this is part of kind of the service orchestration piece of things. There's obviously environments where you may not need to do this, but when you get into elastic environments and you have servers coming in of rotation, out of rotation, you should consider auto-registering with that Varnish service. Right? If I'm a Tomcat server, I've got a service that needs to come online, an API service, and you spin it up, passing the debug health, then it should come into rotation automatically. Right? You don't want to have to, at 2 a.m. when you're trying to struggle to bring more servers online, having to then say, well, I got them online now I got to put them into rotation. Give me a few minutes while I get these configs updated and push them in. If the thing's online, it should just say, look, I'm here, put me into rotation. And so that's why this slide is called Chef versus Console. Chef will run as often as you want it to run. 5 minutes, 30 minutes, an hour, maybe never. But generally, Chef should be running, right, and keeping those files consistent. And if it is, then you've got an interval to say, well, Chef client runs will happen on the half hour or on the hour. But what if I've got an issue that's happening right now, this minute, and I've got 20 servers that are waiting to come online? I may not want to be twiddling my thumbs for 19 minutes while we wait for Chef client to run. So maybe you go in there and you run knife SSH for those particular servers, and you execute a Chef client run. That's how you do it there. But there's other things besides Chef. And it's console. So console has the concept of gossip protocol, right? And things are talking to each other, and they're being made aware of where everything is. And then console template is like a Chef template, where you have basically a file that can get pushed out via console and says, all right, I've just been told that a bunch of servers have come in, and when that happens, when this event happens, I should be writing this file every 30 seconds or every minute, right? A lot less than every half an hour that you might have your Chef client run happen. So the question is Chef versus console, right? Do they go together? Is it one or another? We use both. We use both because you may want to lay down some things with Chef and get that bootstrap to happen. And then if you're saying, well, should we really go to console? You can install the console agents. You can get that running and just have it write a stub file, right? And then if you're comfortable with how it looks, you just have it overwrite the main file, your VCL file, and have it execute your reload. And then when Chef runs again, it's just going to put the same thing that it found with console. It's just the precision, you've dropped it from a 30-minute precision to maybe minute. So if you've got a ramp up of 100,000 users per minute, you can react a lot more quickly. Some best practices. Best practices that we've found, use 64-bit nodes. Obviously, the configuration that I showed earlier said to rely on memory versus disk. And so if you're allocating 2 gigs, 4 gigs, 8 gigs worth of cache, you want to be using 64 bits so you can address that space more quickly. We say to put it behind your hardware load balancers. So you may have an F5 doing load balancing for you, where you've got pools, NetScalers, whatever it might be, and they may be expensive, right? They may be super expensive and very optimized. But we found that by putting our applications directly behind the hardware load balancers also minimizes our automation capabilities, because now we need to use that API for a device that's pretty old, or even if it's modern, API might not be allowed. Security team might say, hey, look, you're not allowed to do this. We don't want you to do this. This is only allowed by the network team, and so you can add members into your pools, but you might not have access to the APIs. In that case, you say, okay, well, I'll just deploy a layer of varnishes, put those into rotation, and those really don't change, and so you can do your work without having to bother the network team to get stuff into rotation, because you've already put it in rotation without them even knowing about it. And that saved us a lot of time. We also say that you should put it in front of everything, and I'll get to that justification in just a bit, because traditionally people think, well, Varnish goes in front of an HTTP web server, Apache, Nginx, Light HTTPD, whatever it is. But we also have other things that run HTTP. So Solar, Tomcat, IIS, anything. You can cache whatever it is. And the benefit is that you might have a Varnish server up here that talks to Apache, and then you might have Apache talking to to Tomcat, and in between that you can also implement Varnish. So you can have a multi-tier approach to Varnish. And the benefits of that is that we'll get to the slides later, but you'll see that we can get a lot of data out of Varnish. And that's the value, is that there's a lot of operational logging and visibility that you can extract from it. Another important thing to keep in mind is VCL reload equals 1. That's a huge win, because if it's set to 0, then you have to bounce Varnish every time you want to get a VCL change out. And the impact of bouncing Varnish is that all that memory, all that shared memory is gone. Right? As soon as you bounce Varnish, it starts from 0, which means the requests have to go back to the back end, store some cache, and then start serving from there. So you want that capability. gzip compression, we've noticed that load tests with and without gzip make a significant difference. There's a lot more time spent uncompressing versus just letting the clients, versus Varnish just sending the clients gzip-based content. You got to tune your TTLs, absolute must. I think the main win for us is that with the development teams that we work with, we've essentially deployed it and say, look, we're not going to do anything fancy. It's very basic default Varnish configuration file. It's going to receive whatever comes in, and we're just defining the backends. That's all we're doing. We're using default TTLs in this case. Maybe it's 5 minutes, maybe it's 2 minutes, maybe it's 1 minute, and we just let it run, and we start collecting metrics. You start seeing how many misses you have. You start seeing how many hits you have. And then, maybe they come around and say, well, we actually noticed that there's a lot of misses on this, and we'd like to optimize that. And then you go, okay, all right, now we can have a conversation about what this particular endpoint, what this particular path should have in terms of a TTL. Right? How long should we hold on to that response before going back against the backends? And as soon as you do that, there's exponential savings in terms of response time, in terms of performance. Now you're relying just on Varnish and not the backend as much. And so that's been a huge win for us. We also load test regularly. Typically, not every app release, because we've got other monitoring tools that show us how things are going, but generally maybe once a month, 1 to 3 months, we're load testing to see what Varnish can do, especially with app releases coming out, new functionality happening within the application, wanting to understand that cache hit ratio, the response time to those new things, and that ultimately leads to having a test plan that you or the engineering teams come up with and say, look, do we want to test these new TTLs? You test with Varnish, you test without Varnish to see the differences, and it'll be pretty staggering. Grace mode, saint mode. Within VCL, there's the concept of grace mode and saint mode. Grace mode is great because if the backends are unavailable, so let's say that you were serving some content and something happened and they just go offline, right? Or you have a network failure for some reason behind that point, or you have you do a rolling restart and for some reason they don't come back, right? They don't come back, and what grace mode does for you is it keeps that cache that it had and it serves it up. Whatever it's got, it serves stale content. So, but at least it's something, right? So you might we actually sometimes invoke that for maintenance. Right, we'll look at our cache efficiency, and we'll say we've got a 99% cache hit ratio here. There's a lot of cache. We don't have absolutely everything for this particular endpoint or this site or this section of the site. And so we feel pretty good that that 1% is the stuff that people never hit, right? Because with, well, not never hit, they just don't hit it very often. Right? It's just like, it's an optimization strategy. You used to say, we're serving 99% of our site through Varnish, and that 1% falls through, but we're willing to take that hit for that 1%, or that 10%, or the 20%. And so what you can do is you can enable grace mode, take the back ends down, you're serving up that 80% from cache. The saint mode is similar, and they play together. Saint mode is, what if my web server, somebody deploys a template, right? A groovy template goes out, and boom, all of a sudden 500s. Right? And so grace mode, saint mode says, if you see 500s, then serve stale cache, served based on what the grace is. So you can kind of save the developers from themselves sometimes. However, that could really bite you because you honestly, you really want that 500 because you don't want to just put in some sort of stopgap for that. But you can do that, right? If it gets to a point where you need to do that, you can do it. And the last one there is NCSA extended logging to Logstash. This is probably the biggest win is NCSA. Everyone's familiar with Apache like log file formats. Extended logging is that same sort of long file, except the difference is that it adds the back-end response times to it. I talked about load testing. Load testing is important. We use various tools like JMeter and BlazeMeter. Here are some load tests that we've run recently. You can notice here that the green line starts at the bottom, jumps up to the top as soon as it gets it in cache, and then it serves it from cache. This particular application was a S3 backend with a 200 kilobyte HTML file in S3. And we've got another one. I guess that's it. Health checks. ELBs. When you put a Varnish server into a load balancer above it, you want to know that the Varnish server is healthy. So we've used that cache health check so that you know whether to pass traffic to Varnish, right? Because how do you know whether to pass traffic to Varnish or not? You put that synthetic URL, right? You just make it up and you just put it in the VCL receive and it will respond on its behalf. And that way you don't have to go back to the backends to look for health. And this tells you quickly whether Varnish is healthy or not. And let's see here. So we use the combination of things. We use Logstash, Elasticsearch. We use New Relic. Oh, is that okay? Sorry, going back to that load testing. Here's the load test that pulls a 200 byte JSON file from S3. And we had almost 500 URLs in that plan, which totaled about 100 kilobytes in memory. And at the very beginning, we saw 150 millisecond ramp to S3. Once we had it in cache, it dropped down to 10 milliseconds, and we were able to do about 12,000 requests per second on a C3 extra large. So 12,000 requests a second. You know, if you've got mobile configs, you've got application configs that are just reading JSON files. You know, you've got something that publishes JSON files or JSON objects. This is a type of throughput you can expect. I talked about Elasticsearch. Those of you familiar with Elasticsearch, you can create histograms. This particular histogram is itemizing out 200s versus 300s versus 500s, right, and laying them out for you so you can see what your efficiency is there. Mean response time. This is what the extended logging gets you. You can find out if you have an issue with a backend. And obviously you've got a pretty low backend response time, and then all of a sudden you've got some spike, right? And so you know you need to look at it. Max response time, this kind of collects all the above and says, you know, what's been my max response time? Maybe that was a massive hit all at once. There was a thundering herd that hit us, and we had a backend response time, but then it dropped down. New Relic also has there's plugins for Varnish that you can install and just throw everything at New Relic if that's where you're collecting all your other things. Keep it in one place. Build dashboards. This one shows backend traffic. This one shows hit rates. DevOps. Before we close up here, I say resistance is futile. I think one of the big things that we see from engineering teams is that you know, they don't want to lose control of their application, right? They don't want to lose the fact that, hey, you're modifying the behavior of my app. And it's definitely a conversation that you have to have with them to say, well, look, let's test this out. Let's see the benefits of it. And then once you see the benefits, I think there's a lot of growth that can happen, a lot of tuning that can happen. It eventually becomes a tightly coupled thing where you're saying, look, now we're protecting the app. We're also making it more efficient for end users. You can do things like path-based routing. So they'll go to you and they say, you know what, we want this new app, but we only want to get this much traffic from here and send that off to there. Can we do that? Like, well, that's either an I rule typically, or now it's VCL, and we don't have to do that. Collaboration on load tests. Get the load test plan from your engineers. They're deploying some new code, some new endpoints, new service points. Get it from there. Test your code. It's code, so you can say, if I'm expecting this 300 to come back from here, you should be able to write a unit test that says, I'm expecting a 300. Did I get the 300? Did I get the 301 with that specific URL? Lastly, pre-warming. Pre-warming is something that you can do. So if you say that this new endpoint was deployed, somebody hit publish, and this new page is available. If you know it's available, then you can say, well, just hit Varnish and say, with the curl, hit it, and before the public does, so that it's already in cache. So you can kind of pre-populate your cache, and we call it pre-warming. This is pretty much it, guys. Performance matters. That's a big win, right? Keeps people happy. We see sub-second response times in most case. Obviously, you've got JavaScript, et cetera, that could take a while to render, but you don't want that to be that time to be taken in the actual generation of the page. And you can profit by implementing Varnish, increasing your scale, manageability, and resiliency. That's it. So I've gone over, but you guys questions, feel free to ask.
When you set up the VLC for a feed, and you know how you talked about you could say if it's static content like a JPEG or JavaScript file or whatnot, be handled here. Is there anything preventing you from saying, hey, handle that from a CDN service, a completely separate service that is already set up? Like I want to use that previous infrastructure that I already subscribed to and set up on the site, but also take advantage of Varnish and like reporting aspects of the site.
Yeah, so the question was, what happens when traffic comes in for a static asset that you might have on the server, but you want that traffic to be served off CDN? So can you set up the CDN as a backend? You can, but the question I have is, why would you do that if you should probably be referencing that asset at the front end so that it's offloading. So because that means it comes in to your network, hits your Varnish server, and then would have to go out to the CDN to get an asset that's already behind it, right? So what you do is you just, program the CDN at the top so that it kind of offloads from the traffic. So the CDN should definitely reduce the traffic that's coming to you. We've used Varnish as a CDN origin, right? So you might have a separate cluster for media files, right? You might have a separate cluster of media serving farm. And you can put Varnish in front of that. It's super efficient, and just point your CDN at that. But going back out to the internet, not super efficient. We've done that before. We've had to integrate with a third party that was a disparate location. So you can totally do it. It's something you should monitor and check the response time to make sure it's within healthy norms. Yeah. So as long as so we're talking about HTTP, right? So comes in and you say this needs to go to Redis or needs to go to any HTTP backend. You can set it as a backend. Yeah.
Okay, so the second question, the second part of the caching question is, can you define custom, so you have a key, for example, can you define the custom, object, so the Varnish will use, so for purpose of, like pre-caching, for example, from another service. Does that make sense?
I'm not sure I follow.
So Varnish has its own, like, it has a key, right?
Mm-hmm.
Where to go to,
yep.
and it has the actual value. So is it possible to set the value like something custom? Like say you have like date when it was cached, like a JSON object with like date, some other data that's used by the application, and the actual cache in the data.
That would be if you were to do that. If that capability existed, it would be in VCL hash, right? And how you manipulate the cache keys. You know, I'm not sure. I'm not sure. Okay.
How would you handle something like PHP sessions with Varnish?
PHP sessions. Yeah, you got to be careful with those. So we've, I remember the early days when we were testing things out in our dev environment. We had situations where, you know, cookies are being passed and they're being cached, and then all of a sudden, you got more than one person logging in. It's like, wait a minute, I'm seeing Joe's, you know, page. You know, it says, you know, hi Joe, and you know, you've got the bar at the top, and maybe it's WordPress, right? Et cetera, and that's bad, and you absolutely don't want to do that. You can do two things. You can make sure that you're not caching those specific things for those sessions. You can avoid caching at all for that specific type. So there are things like WordPress, right? You have a /WP admin section of the site. You could opt to not cache that at all, and just restrict it from that. So it's not like it goes to different backends. Maybe you do have admin specific WordPress servers, but you can you know, again, strategize and say this specific content has special requirements. So if you're going to you know, a cart or a login, an admin login that needs credentials and cookies, then you got to make sure that you're handling that in VCL receive properly. So you're setting those things, or you're unsetting them if there are specific paths, and then or not caching those. Right? So again, if you've got a specific path that shouldn't be cached, you just pass it on through without cache for that specific URL.
What's your solution for SSL termination?
That's a good question. I'm glad somebody asked that because Varnish. Oh, so the question was SSL termination. What's the solution? What's your solution for SSL termination? We've looked at multiple things, and Varnish isn't one of them for SSL termination. So it does a lot of great things, but it doesn't do everything well. And I think that's a real strong factor for Varnish, and it's a strong factor for a lot of different technologies where it does one thing really well. And they've looked at SSL, and you know, I've seen some articles and the responses from the architect behind Varnish says that it's really, really difficult to have a super secure OpenSSL library, right? And try to build that termination within the app and making sure that you don't fumble something incorrectly where it could lead to vulnerabilities. So he wants to limit his scope of responsibility for SSL and say, we just want to focus on HTTP acceleration and do that one thing very well. And I did see that, you know, there's lots of different technologies out that do SSL termination. We do it in hardware with appliances above Varnish, and then just hand it off. We also do it in non-production environments using HA proxy, right? HA proxy has SSL termination capabilities built in, you know, so that's what we do. Yeah. So hit for pass in Varnish, that's the complex one. Let's go back here. Hit for pass is where you've got, one of the cool things is that Varnish can receive tons of connections, right? Based on what your min and max threads are, it comes in and it basically holds the thundering herd because it'll take care of one request, and then it'll say, I've got 1,000 requests for this one object, and all these 1,000 requests are coming for one object. Now I want that one request to handle the back end. So you don't see 1,000 requests at the back end. You see one request at the back end. It kind of funnels all of them into one request and then responds. That's a normal. That's a hit, right? That's a hit for pass. What it does is basically it says, I've funneled everybody. I've got them in, but the problem is that this is a zero TTL object. So for some reason, someone's coded a zero TTL thing, or the back end has said, hey, I'm not cacheable, right? Because you can have applications. This is one thing that you should do is that application developers should be telling Varnish what's cacheable and what's not cacheable. So if something's not cacheable, you know, if a particular API endpoint is not cacheable, shouldn't be treated as cacheable, then Varnish basically says, well, when it's doing its VCL deliver, it says I'm essentially doing a pass, right? So it goes through, and it's instead of doing a standard cache mechanism, it basically says don't store in cache and go to the back end. So it's almost like it's a hit because it knows about it, but it also knows that it shouldn't be cached. So those end up just going straight through.
You mentioned for the probe declaration where you check the health for the backend, that the
Yeah.
file to check, does the file have to have any kind of content or just the file has to exist? Yeah, it's there. So you have that URL, right?
Yeah.
Pointing to that file.
Uh-huh.
Does the file have to have any kind of content in it or just has to exist?
It just has to exist. You can actually check the response code for that. So you can create a probe that says expect a 200 for this. You can go more detailed than this. It's actually there's a capability that you have with this. So let's say that's a static file and it's not a dynamic file. Typically these are dynamic endpoints. So let's say it's a debug health endpoint that you've just created right within your application, and you say I'm going on behalf of Varnish, I'll give them this URL, and maybe it runs through some things, maybe it does some basic check to if I'm healthy, I'm going to respond with a 200, and that's that endpoint. If it's a static file, and then it will always exist as long as the file is there, right? It will always return as long as Apache's running, or your web server is running, and as long as the file exists. With a flat file, you can actually remove it and then take things out of rotation that way. So you've actually built in like an in rotation, out of rotation mechanism by doing that, by using a file. We generally do dynamic probes where the application has to respond on its own to say whether it's healthy. And so, there are certain things that you can do with an application to say, if you see this, then make that endpoint respond with a 500 versus a 200. So this service here is not a flat file. This is a dynamic backend probe. You can create a flat file. It can be a flat file, and that would probably be appropriate for web servers that are serving static assets. All right.
So you mentioned AWS and like some way, aside from that, some ways of logging Varnish data results.
Mm-hmm.
Do you have any experience with pushing that data to CloudWatch, for example, or custom metrics?
Yes. What we do with CloudWatch is really for our elk stack. Right? So we have Varnish logging into a big cluster. I mean, there's probably another presentation that you can go dedicated into how to do this. But essentially, we have it going not into a file server. We have it going into Logstash. So Logstash agent is watching the files on the server and then shipping them off to Logstash server. We do that instead of going from a Logstash agent that's running on the node directly to a Logstash server, which is then dumping it into Elasticsearch. What we do is we go from Logstash agent into a Redis queue. That Redis queue is then monitored by CloudWatch. CloudWatch then is saying, well, I'm seeing this many, this is the queue length, queue depth. So you monitor queue depth like that, and Redis will tell you what that is. And if it's over 200,000 things, then bump up the Redis, bump up the Logstash server. Right? So you can kind of automate it and say, if I see greater than 200,000 queue depth, then increase this by 50%. Yeah. That answer your question? Okay.
How do you decide versus like Nginx or Squid and Varnish?
Yeah, we like Squid. We like Nginx. When we looked at all of them, we looked at config files. We saw what config file do I like to work with. We saw performance tests. Right, so we were looking at Nginx versus Varnish versus Squid. The Squid configuration file is long and it's confusing, and it reminds me of SendMail config files. So right off the bat, and I've used Squid a lot in the past. The problem is that it also runs on disk. Right? The storage, maybe the modern ones use memory, but classically it was always stored on disk, which is slow. Right? Now you got to worry about I/O to a disk. maybe with a solid state disk, not that much of a problem. But so kind of SCWD was off the table to begin with, just because classically this was designed to be better than SCWD from the get-go. They used SCWD as kind of like, this is our competitor. And with that in mind, and with the configuration language, with the flexibility that it had, with Nginx, we've had issues with cache corruption. So we'd see, the cache would corrupt every so often. It's like, got to bounce the thing. So we've just been a lot more reliable, and the load tests are super important. There's some features within Varnish, like when you want to copy a header and take it somewhere else, instead of actually copying the content of the header, it basically references it to the pointer and copies it that way. So it's super efficient in the way it works.
So for a monolithic application, how to prevent the case where you put the production and then you have to validate all the cache, and therefore you have to cache from scratch? Is there a way to like pre-batch everything that used to be in the cache that used to be a hit, and then without being externally hit by a kernel, for example, or that type of stuff?
So you deploy the application, and you basically have to, you want to prevent it from being overtaken by the thundering herd that's coming to get it, because it's new. Are you up next?
I am.
Yep. All right. I think. Can we take that offline?
Sure.
Yeah. All right. Okay. Thanks, everyone.